For generations, humanity has lifted its eyes to the stars and whispered a single, timeless question that refuses to fade. Are we truly alone in this vast, endless universe? Or does something, somewhere, whisper back? From ancient tribes who etched constellations into stone, to sailors who navigated oceans guided only by the heavens, to philosophers debating by candlelight about unseen worlds, to scientists who built instruments capable of catching the faintest glimmer from the void, this question has never left us. It has echoed through the corridors of time, a haunting refrain passed from one era to the next, drifting like starlight through the infinite dark. Science gave us probabilities. Mathematics gave us elegant models. Physics gave us theories, strange, beautiful, and sometimes terrifying. But none of them gave us certainty. None of them gave us proof. Until now. Just 120 light-years away, a gulf that would take countless human lifetimes to cross, yet on the grand stage of the cosmos, it is only a single step. There burns a small red dwarf star in the constellation of Leo. Circling that dim ember lies a world unlike any we have ever known. Its name is K2-18B. And through the golden mirrors and infrared eyes of the James Webb Space Telescope, we have glimpsed something extraordinary, perhaps the very threshold of the answer humanity has sought for thousands of years. When Webb turned its gaze toward this mysterious planet, the data it returned sent ripples through every scientific community on Earth. The skies of K2-18B were not barren, not silent, not sterile like the countless alien atmospheres we had studied before. Instead, they sang, a cosmic symphony of molecules, a chemical fingerprint written across light itself. There was water vapor. There was methane. There was carbon dioxide. But nestled among those familiar signatures was something extraordinary. Something that should not exist on a dead, lifeless world. Dimethyl sulfide. On Earth, this compound is not born from volcanoes or storms. It is not sculpted by geology. It is created almost entirely by life. Tiny phytoplankton drifting in Earth's oceans exhale it as part of their natural rhythm. To find this chemical suspended in the alien skies of K2-18B was beyond astonishing, it was transformative. Suddenly, the search for extraterrestrial life was no longer only a theory. It was no longer a dream painted by science fiction. It became chemistry. It became biology. It became evidence written into the light of another world. And K2-18B, as it turns out, is no ordinary planet. It belongs to a rare and wondrous class scientists call Hycean worlds. Planets cloaked in thick hydrogen atmospheres, possibly hiding vast global oceans beneath their shrouded skies. Imagine a planet 2.6 times the size of Earth, with almost 9 times its mass, orbiting close enough to its small star to keep oceans alive and liquid. Neither a frozen wasteland like Mars, nor a chaotic gas giant like Jupiter, but something in between. A world wrapped in a gentle hydrogen blanket, shielding it from deadly radiation, balancing its temperature, and turning it into something more than a mystery, a candidate, a cradle, perhaps even a home for life. And then came another revelation. Alongside DMS, Webb detected its chemical twin, dimethyl disulfide, DMDS. On Earth, these gases rise only from the breath of living ecosystems beneath the ocean's surface. Finding both together, along with water vapor and carbon-based molecules, was statistically extraordinary, a signal that could not be ignored. Scientists checked the data once, twice, a third time, and then, in quiet awe, whispered a word they had always feared to speak aloud. It is more than science. It is wonder, imagination, and the story of our place in a universe far larger than we can grasp. When a planet like K2-18b reveals fingerprints that should not exist without life, It doesn't just challenge our theories, it challenges us. For centuries we believed Earth might be unique, the single blue oasis in a cosmic desert. But now, across 120 light-years, a distant world whispers the opposite. Life may not be rare at all. This realization stretches far beyond laboratories. It seeps into philosophy, culture, even spirituality. It asks what it means to exist, and what it means to be known. Scientists argue about the next step. Some urge silence, fearing that communication could disturb a fragile alien biosphere, or expose us to dangers beyond comprehension. Others argue it is already too late. For over a century, our radio waves have spilled into space, rippling outward like echoes on water. If someone is listening, they already know we are here. Yet even if they heard, communication is painfully slow. One message would take 120 years to arrive. Another 120 to return. This is not a conversation. It is a message across time, a legacy from humanity to the stars. When Webb's discoveries became public, the world ignited. Headlines blazed across screens. Social media erupted with tags like hashtag K2-18B and hashtag AlienOceans. For a brief, shimmering moment, billions of people looked up together, not divided by nations but united by wonder. Children asked about telescopes. Space agencies rewrote their missions. Private companies dreamed of new frontiers. And ideas once trapped in science fiction began to feel suddenly possible. But with that excitement came an echo of an older question, the Fermi paradox. If life is common, then why the silence? Perhaps civilizations burn out too soon. Perhaps intelligence is fragile, too brief a spark against the cold backdrop of eternity. Or perhaps silence is not emptiness, perhaps silence is survival. Even finding only microbes would change everything. It would mean life can flourish under skies completely alien to ours. But if we ever find more complex ecosystems or intelligence, then the silence of the stars may be not a mystery but a warning. Speak carefully. K2-18B also challenges how we define life itself. On Earth, we depend on oxygen, carbon, and water. But on K2-18B, hydrogen rules. Could life breathe hydrogen? Could photosynthesis bloom beneath a red dwarf's glow? To answer that, scientists study extremophiles, organisms that thrive in boiling acid, frozen oceans, crushing pressure, or radiation. Once seen as exceptions, they are now our guides to imagining alien biology. And maybe, just maybe, we have already overlooked hints, unusual meteorites, chemical traces dismissed as noise, clues we were not yet wise enough to recognize. Before K2-18B, we looked outward with curiosity. After K2-18B, we look outward with responsibility. Religions revisit creation. Philosophers rewrite meaning. Teachers prepare to guide a generation that may grow up knowing, we are not alone. Some respond with awe. Others with fear. But none remain unchanged. Because K2-18B is more than discovery, it is a mirror. It reflects who we are, who we were, and who we may yet become. For ages we thought life was a lonely spark in a vast, silent night. Now, a new whisper reaches across the dark. Life may not be a miracle confined to Earth, but a pattern written into the very fabric of the universe. And that whisper is not an ending. It is a beginning. A question reborn. Are we alone? Do we remain silent? Do we dare to reach out? Or do we wait, patient, careful, listening, for the universe to whisper back?